Hi everybody, we're going to be talking about notes on how to solve one-step inequalities today from the 7th grade Common Core Standards. We are going to follow the same procedures that we followed for solving one-step equations. The difference is going to be there is an inequality in the first part of the examples. So we are going to isolate the variable. During this video, at any time you need to pause, you should be doing so. If there are questions that you have, you should be writing them in the margins and be prepared to ask those questions. Be prepared to start and stop. All right, if you need to watch something more than one time, watch it more than one time. I also recommend starting and stopping through the whole video and then going back and rewatching the whole thing straight through again to kind of get a better understanding. The goal of these notes is for you to come in and make sure you have a good understanding of what the heck I'm talking about. So, in the first example, we are going to be isolating the variable, and it says that 3x is less than 1/4. I need to identify what's happening between the variable and the coefficient. So 3 and x are next to each other, so they're being multiplied. In order to go ahead and eliminate the 3 from the x, the opposite of multiplication is I'm going to divide both sides by 3, and I'm going to do that the same way I would as if I were to have an equation. So I'm going to divide both sides by 3. Okay, 3x divided by 3 is x, so I'm just left with x on this side. Now, I need to take 1/4 and divide it by 3. I'm going to do that math over here, and when I divide by 3, that's the same thing as multiplying by 1/3. So over here, we've called it a timeout. We've kind of done the work on this side. So I know that x is less than 1/2. That means any answer that's less than a half when I put into the inequality and evaluate is going to make the statement true. So I can pick anything that's less than 1/2. So x is less than 1/2. If I were to graph it, I would go ahead and put an open circle on 1/2 because 1/2 is not included in the solution. And I would make sure I'm shading the line, including the arrow, to indicate everything I've shaded could make that statement true. In the second example, x is being added to 1/5, or 1/5 is being added to x. In order to eliminate the adding of 1/5, I'm going to add negative 1/5 to both sides. 1/5 and negative 1/5 is going to be 0, so I'm just left with x on this side. And so now I have negative 1/2 plus negative 1/5. Because I'm adding negatives, I don't have any zero pairs, so I'm just going to add both of them. So I'm going to add 1 1/2 plus 1/5. When I add fractions, I need a common denominator, which in this case is going to be 10, and this is going to be 3/2. So that's 2 times 5 is 10, and 3 times 5 is 15. This is 10, and that's going to be multiplied by 2. I have 17/10. I can also make that 1 7/10. They both were negative, so my answer is negative 1 7/10. If I were going to go ahead and graph that, I'm going to put in closed circle, a negative 1 7/10. The closed circle is because there's a line underneath the greater than symbol, which indicates that negative 1 7/10 is included. I'm going to shade the line as well as the arrow to indicate anything that I've shaded could make that statement true. On my next one, if I were to go ahead and isolate the variable, x is being divided by 0.5 or 5/10. In order to eliminate that, I need to multiply both sides by 0.5. So I'm going to multiply both sides by 0.5. 5/10 x divided by 5/10 is simply x, or 1x. I then am going to go ahead and take my little timeout over here like I did on this side, and I'm going to multiply 1.5 or 1.2 times 5. That ends up equaling 6/10, and one of them is negative, so my answer is negative 6/10. If I want to graph that, I put a closed circle at negative 6/10. All right, and I'm going to shade to the left because those are the numbers that are less. Okay. This is very similar to solving the one-step equations. The last 3 examples are different. When we're talking about negatives and inequalities, when we're multiplying by a negative, because negatives are farther away from zero the larger they get, it causes a problem when we multiply negatives and divide negatives in an inequality. So if you are dividing, oh, that should be an or, not an of, dividing or multiplying by a negative, switch the direction of the inequality. If you don't do this, the statement will not be true. So, not if there's a negative in it, but if you're dividing or multiplying by a negative. So let's look at our first example. I have negative 4x. I need to isolate the variable, so I'm going to divide both sides by negative 4. By dividing by a negative 4, x is no longer less than, x becomes greater than. Because by multiplying by the negative 4, I have to switch the sign of the inequality. Over here, I'm going to do 1/5 divided by negative 4, which is 1/5 times negative 1/4, and answer is negative 1/20. So any number that is greater than negative 1/20 is going to make that statement true. In example 5, when I divide both sides by 3, x is still going to be greater. And the reason it's going to be greater is I divided by a positive. There was a negative in the problem, but because of what I'm dividing by is a positive, this direction of the inequality does not switch. So I do 4.2 divided by 3, 1.4. So my answer is negative 1.4. It stayed greater because I divided by 3 and not negative 3. In my last example, x is being divided by negative 2. So I'm going to multiply by negative 2. That should cause a red flag that tells me x is no longer less than. X is now going to be greater than. So x is greater than, and then whatever negative 1/3 times negative 2 is, I'm going to doodle it over here. Negative 4/3 times negative 2/1, positive 8/3, or I can have 2 and 2/3. So the top 3 examples are just like what we did in solving equations. The bottom 3 examples, when multiplying or dividing by a negative, I divided by a negative, so it went ahead and changed the less to a greater. I divided by a positive, so it didn't do anything at all. And in my last example, I multiplied by a negative, so the symbol went from a less than to a greater than symbol. All right, anything I write down, you write down. All right, make sure you're writing any notes or questions that you may have on either side. Thanks, guys. Have a good one.